In this video, we're going to talk about Le-Chatelier's principle. So Le-Chatelier's principle simply states that if you have a system at equilibrium, and you try to put some stress on the equilibrium by changing the concentration or changing the pressure, volume, or the temperature, the equilibrium is going to shift to counteract the stress. Okay, so that's basically what Le-Chatelier's principle states. So let's take, for example, the reaction N2 plus H2 gives us NH3. Let's go ahead and balance it. So let's say we have this reaction. This reaction is at equilibrium. According to Le-Chatelier's principle, if we do anything to change the equilibrium, the reaction is going to counteract that change or that stress. That's what the principle says, stress. It's going to counteract that stress or the change by shifting the equilibrium to accommodate the change. So one way to kind of relate to this is if someone pushes you. So let's take my example. If my left hand pushes my right hand, then my right hand is going to try to push back to counteract that push. Okay. So there are three scenarios we're going to look at. Scenario number one is change in the effect of change in concentration. Scenario number two is the effect of change in volume and pressure. And scenario number three is the effect of the change in temperature. Let's focus our attention on scenario number one, which is the effect of change in concentration. So there are two scenarios that can happen out here. Change in concentration of the reactants or change in concentration of the products. So if the reactants, it doesn't matter which one, any of the reactants. So if the concentration of the reactants, if you increase that concentration, then that will shift the equilibrium towards the right. So if you increase the amount of concentration out here, that means you've put pressure on this side of the system. So the equilibrium is going to shift to the right. That means towards the products to basically counteract that change. Okay, so we said that equilibrium shifts to the right, which means more products will form, which means product go up. What if you decrease the concentration of reactants? If you decrease the concentration, then the equilibrium, so you're reducing the amount out here, which means the equilibrium is going to shift to the left, which means the product concentration is going to deplete because it's going to try to make more of the reactants to counteract that change. Okay, so equilibrium is going to shift to the left, so more reactants will form. Let's talk about the products. What if I increase the concentration of the products? Okay, so in this case, it's the NH3. If I increase the NH3, it's going to be too much NH3, so it's going to shift the equilibrium to the left to counteract that increase. So equilibrium is going to shift to the left. As a result of that, more reactants are going to form. So reactants go up. And if you decrease the concentration of products, so if you take away NH3 as it's formed, you're going to have the equilibrium shift to the right, which means more reactants are going to, the reactants are going to make more product. Okay, so equilibrium is going to shift to the right. And as a result of that, since the reactants are making more products, the reactants will go down in concentration. So if you decrease the volume out here, what's going to happen is, think about it. If you're decreasing the volume, that means the pressure of the pressure inside the system is building up. Okay, because you just constricted the vessel, you decrease the volume. So if you're decreasing the volume, then the system is going to try to relieve that excess pressure. And the only way it knows how to relieve the excess pressure is to shift the equilibrium to the point where the pressure is lower. And so how do you know which point has lower pressure? So look at the reactant side. The reactant side has 1 plus 3. That's 4 moles. Okay, 4 reactant moles in this reaction, and this one actually has 2 moles. So if I had to ask you a question, which side has fewer moles, it's going to be the product side. So therefore the equilibrium is going to shift to the product, so it's going to make more products so it can reduce the pressure of the 4 moles and make it 2 moles. So equilibrium is going to shift towards the reactant side of fewer moles, because that's what's going to reduce the pressure. Conversely, if your volume goes up, that means if I reduce the pressure of the system to increase the volume, then the equilibrium, so now it's the volume is up, the pressure went down, so the equilibrium is going to shift towards the side to bring the pressure back to what it was. So it's going to shift in this particular reaction, going to shift to the left to make more moles. Okay, so therefore equilibrium shifts towards side of more moles. So let's say this is my reaction container and I added argon, which is an inert gas, to the container. Well, argon's not going to react with anything. All argon's going to do is take up space. When it takes up space, it's actually going to change the pressure of the partial pressures of the gases. Okay, not the partial pressure. It's going to change the volume that the gases occupy. As a result, it's going to change the pressure too. But what it's going to do on one side is going to be the same for the other side. Therefore, the equilibrium is not really going to shift. Okay, so there's going to be no change. Okay, no effect. On equilibrium if you add an inert gas. And the last scenario is, what if we had a reaction where we had the same number of moles on both sides? Okay, so I'll give you a fictitious reaction. A plus B, equilibrium goes to C plus D. Same number of moles on both sides. So no matter what you do to change the volume out here in this particular case, it's not going to have any change on the equilibrium, simply because there's no way it can shift to change the equilibrium. So the equilibrium is going to stay constant. So the third scenario we'll look at is the effect of temperature. So let's say you have a reaction, A plus B gives you C plus D, and let's say out here delta H is a positive quantity. So let's say delta H is 91 kilojoules per mole. So delta H is positive. When delta H is positive, that means it's an endothermic reaction. Endothermic means as you go from reactants to products, the reaction is going to absorb energy from its surroundings. It's going to absorb heat energy from its surrounding, and so it's going to cool off the surroundings. Okay, which means that if you equate this in terms of heat content, you can think of that the reactant side has the 91 kilojoules per mole of energy. So in this particular case, when you increase the temperature, the equilibrium will shift to the right, because when it shifts to the right, you see there's no longer any more heat on the right, so it absorbs that excess heat. Okay, so more products will form to counteract that stress. If you decrease the temperature, equilibrium will shift to the left. Okay, so more reactants will form because it wants to elevate the temperature back to what it was, because you're decreasing the temperature. Okay, now what if this was an exothermic reaction? So if I change this to a negative quantity, then that would be negative, and then this would be exothermic. So if it's an exothermic reaction, that means the reaction in going forward actually produces heat. So that 91 would end up on this side. Okay, so that heat will be given off as a product. Now, so if you increase the temperature, you don't want to go this side because there's excess heat there. So you're just adding more to more. So what you want to do is, if you increase the temperature, this C and D is going to try to convert to A and B to absorb that increased temperature. So the equilibrium is going to shift to the left and products are going to decrease. Conversely, if you decrease the temperature, if you drop the temperature, then A and B is going to try to make more of C and D to bring the temperature back up. Okay, so the equilibrium is going to shift to the right, and the reactant quantity is going to actually go down, and products are going to go up. I hope that made sense.